This video introduces our Zenon performance calculator, followed by a step-by-step guide on how to use it. It's been created to demonstrate the effect that our different insulation options have on Rooflight performance for the typical Zenon Pro and Zenon Evolution assemblies. To understand where to start, we need to ask ourselves, what do we really want from the Rooflights in our metal building envelope, and what is important to us? Some of the key specifications to consider are: we want the best possible light transmission, because after all that's the fundamental reason that they're in the spec in the first place. We want the best thermal performance, because if they just let all the heat out, any daylight benefits, such as energy savings, are completely eradicated by the heat loss. And we want the people who go up onto the roof of our building to come back down safe and well, so we want absolute, irrefutable non-fragility, and that's non-negotiable. We need to know what their G value is, and we want the lowest embodied carbon in the building fabric wherever possible for an increasingly energy conscious industry. The question now is, can we have our cake and eat it? Can we achieve the best light transmission, heat retention and non-fragility all at the same time? And where do G value and embodied carbon fit into the picture? What's the overall result going to be when we start to mix up those characteristics? The reality is that if we want to make a change to the Rooflight's performance characteristics, we have to change one or more of the elements of its makeup, and every time we change part of the Rooflight, it can impact on something else. You'll find this performance calculator if you go onto the Zenon Rooflight section of the Hambleside-Danelaw website. Let's see how changes to Rooflights impact on their overall performance. It's not set up to give you information on every possible combination, but it does give you an insight into what can be achieved with different Rooflight assemblies. It's important to point out too that the data behind this calculator has been produced from actual physical testing by the National Physical Laboratory in Teddington. So all that said, here's the calculator. It's pretty simple to operate. Step 1, depending on what cladding system you're using, choose either site assembled for a built-up roofing system or factory assembled for a composite panel roof. Let's just go with site assembled for demo purposes. Step 2, choose either the conventionally reinforced product range or the woven lightweight low carbon reinforcement. Let's just go with conventionally reinforced, which is Zenon Pro for now, because that's the one that reflects the most commonly used materials in this sector. Step 3, choose the insulation component. For now, we'll start with 4mm twin-walled polycarbonate because that gives us the baseline U value required by the regulations. Now when we click on the Go button, the calculator is going to show us the percentage of light transmission, the thermal performance or U value, the total solar gain or G value, and the embodied carbon contained in this particular build-up. Let's click on Go and here's what we get. Here's the construction we've asked for. You can see the outer skin, the inner skin and the polycarbonate material. Now for the important information. We get our 1.7 watts per square metre Kelvin baseline U value. We get 53% light transmission, 52% G value, light and solar transmission always going to be pretty much hand in hand. And we get 21 kilograms of embodied CO2 per square metre. Now let's think about improving the thermal performance. We can better the U value by changing the 4mm polycarbonate and replacing it with a 10mm multi-walled polycarbonate sheet. So let's do that and let's click Go. And here's the result. You can see that we've improved the U value as planned. We now have 1.3 watts per square metre Kelvin. But look at what else has happened. Because there are double the layers or reflective surfaces in the 10mm product, we've reduced the light transmission from 53 to 43%. If your solution to further improve the U value is to just add more layers of polycarbonate, then your light transmission really is going to start to suffer. Because the G value and the light transmission have a direct relationship, the G value has gone down as well to 44%. Now a point on G value, remember heat gains from the sun's energy can be a positive thing and reduce heating demands throughout most of the year. But the risk of overheating the building in the hottest few weeks of the year should be considered in conjunction with an effective ventilation strategy. We've also paid a carbon penalty. This new build-up has added 2.4 kilograms or 11% of embodied CO2. We've gone from 21 kilos to 23.4. Now what if we really want the best non-fragility scenario? If you wanted to do that using conventionally reinforced GRP sheets, then you'd need to increase the weight of the external sheet to 3.6 kilograms. The calculator doesn't have that level of detail and will only show typical results, although I can tell you what will happen. It will add a further 5.55 kilos, an increase of 23% of CO2, reduce light transmission down to 41% and G value down to 42%. There is another way to do it though. Zenon Evolution, the woven continuous reinforcement sheet, gives the same non-fragility as the heavier, thicker, conventionally reinforced materials, and it is a lower carbon option. So let's change the calculator to that and click Go. Now the non-fragility is right, the U value is right, the embodied carbon is right, it's actually lower than the baseline construction we started with, and the G value is reduced, but we've also reduced the light transmission to 35%. There is something we can do to improve the light transmission, and that is to use our Insulator Honeycomb core. And if embodied carbon is an important consideration in your brief, then you'll like this. The light transmission is back up to 46%, and the overall embodied carbon figure has gone right down to 15.2 kilograms. With this final assembly, we end up with excellent non-fragility, good light transmission, moderate G value, improved thermal performance, and all for an embodied carbon investment of 15.2 kilograms. That's 25% lower than the baseline construction we started with. I hope you find this introduction to our performance calculator useful. Now it's your turn to have a go. And for more information on U value, light transmission, G value, non-fragility and embodied carbon when specifying Rooflights, please visit our technical guides on our website, which can be found under Zenon Rooflights. Thank you.